Differential equations. Seems like something really difficult to understand, and one of those concepts in math that we will never use, right? Well, my goal in this video is to show you how differential equations can sometimes be very natural and intuitive, and how they're extremely useful in explaining the real world. So first I have to talk about what a derivative is. Differentiation, or the process of taking derivatives, is really talking about how much something's changing. So when something is not changing, like the number of balls in this container, we say its derivative is 0.
Now, take a look at these two containers.
Which of these is being filled at a faster rate? Yes, this one.
Since a bigger derivative represents more change,
The derivative of the number of balls with respect to time in this container is larger than the derivative in the other container at any moment you watch. Okay, enough with derivatives. Now, why do we need differential equations? Sometimes things change based on how others are changing. We know this from experience, right? When things move, they make other things move.
what's a differential equation? It's an equation that contains derivatives along with some functions.
For just a moment, imagine the rate at which I fill the containers depends on some other thing. So maybe it depends on how the room temperature is changing. Or maybe it depends on the number of balls that's already there. Assuming I know the relation between the rates of change and the variables I have, wouldn't it be interesting to know the exact number of balls in the container at any given time? Well, since I know how the change of one variable is related to other, I can do it by simply solving the differential equation. So the solution to this and other differential equations will be a mathematical expression, a function. In order to understand this better, let's take an example we're all familiar with. Cars.
Imagine a car that just started to accelerate as much as possible. Notice that at first, when it's far from full speed, it accelerates a lot, but when it's close to hitting full speed, it's really hard to accelerate. In other words, the acceleration is proportional to the difference between your speed and the maximum. Congratulations, you've just written down a differential equation. Once the equation is solved, we apply the initial condition that it starts at rest, and you get this expression for the speed of the car. This is how our model compares to the real data from a 2015 Volkswagen Golf. Look how good it fits the model. We were able to get this quantitative model just by stating how the speed changes. This is the real power of differential equations.